Lagrange multiplier with one constraint. We are trying to maximize the objective function f of xy equals to 4xy, where both x and y are greater than 0, and this is subject to this constraint. Constraint is a restriction. X squared over 3 squared plus y squared over 4 squared equals to 1, so this is a vertical ellipse. The center is at 0, 0, and then the length of the major axis, so is at 0, and then you go 4 units up, 4 units down, and then this one, the length of the minor axis at 0, 0, you go 3 units right and 3 units to the left. Okay, so the first thing that we will have to do is we have to get our function g. So this one starting at the constraint, so that tells me the g of xy is equal to x squared divided by 3 squared plus y squared divided by 4 squared. The one, we are not taking the one. And then we will have to take the derivative of that. And then this one will be the gradient of g. So we will just do this. Do 1 with respect to x and then do 1 with respect to y. So the function g with respect to x, so you bring the 2 down and then you have a 2 over 9x. And then that one, what happened when we take the derivative of this with respect to x? That is just a 0, right? Because only x is a variable. And then you take the derivative with respect to y, so the first fraction is a constant because there is no y in it. And then this one, you bring the 2 down, so that will be 2 over 16 y. So 2 over 16, and then y to the first power. And then on the other side, we have to do the gradients for function f. So let's follow the color. So that is the gradient of f, which is equals to the partial derivative with respect to x, the partial derivative with respect to y. So what is that equal to? 4xy, the derivative of x is 1, so you have a 4y. And then the derivative of y is 1, you have a 4x. And then that's it. So the next step is you have to write the Lagrange multiplier. The Lagrange multiplier is we have the gradient of f equals to the Lagrange multiplier, which is the Greek letter lambda, and then times the gradient of g. Okay, so let's put the derivative, the partial derivative, so 4y comma 4x, and then equal Lagrange multiplier, multiply 2 over 9x and then 2 over 16y. And then what are we doing? We will have to multiply the Lagrange multiplier, the lambda, so 2 over 9 lambda x, and then 2 over 16 lambda y, and then the left side, no change. And then we have to set up our equation by doing what? By setting the first, that is like 2 ball. So let's just do, how about this? We will have to set the first, the partial derivative of x equals, and then the partial derivative of y equal. So that means we will have a 4y equals to 2 over 9 lambda x. And then on the other side, we have a 4x equals to 2 over 16 lambda y. Okay, can we isolate lambda on one side and then set them equal? So we have 4y, and then this will be multiply reciprocal 9 over 2, and then divide both sides by x, and then equals to lambda. This side will be a 4x multiply 16 over 2, and then multiply 1 over y equals to lambda. So we have lambda on one side. Before we set them equal, let's clean that up a little bit. The 4 and a 2 is a 2. 2 times 9 is 18. So we have 18 y over x equals to lambda. And then the other side, 2 times 16 is 32 x 1 over y equals to lambda. So we have lambda on one side, and then we set the 2 lambdas equal. So that will be, let's do it right here. So we have 18 y over x equals to 32 x 1 times y. All right. What can we do? Can we put all the y on one side and all the x on one side? So first of all, I will just do 18 over 32. Okay. And then how about multiply the y on both sides? We have a y square. Multiply x on both sides, we have x square. Okay, so what we are going to do next is we are going to plug in this x square into the constraint, which is right there. Do you see that? We are going to plug it in right over there. So that will be 18 over 32. So divide top and bottom by 2. That will be a 9 over 16. And then you have a y square. And then divided by 9. So that will be multiply 1 over 9. And then plus y square divided by 4 square equals to 1. And then can we clean up the 9? So we have a y square divided by 16. And then plus y square divided by 16 equals to 1. So that means we have 2 of that. So can we multiply 16 on both sides? So y plus y is 2y square. Multiply 16 on both sides. Divide both sides by 2. Y square is equals to 8. And then y is equals to plus or minus, right? So the square root of 8 is 2 root 2. Am I right? So that will be 2 root 2. And then y equals to negative 2 root 2. Should we omit anything? Should we? You know what? So they said that x and y must be positive, right? So if you go back to the beginning of the problem where x and y are both positive, so since y must be positive, and then we just omit this. So since y must be positive, and then we have to omit this. So omit. Okay, then we are taking y equals to 2 root 2. So y is equals to 2 root 2. And then what is x squared equals to? I know I got an x square, right? So I got an x square right here. And then I'm going to bring this down. And then to continue my discussion, so we have x squared equals to 18 over 2, which is a 9 over 16. And then y squared, so you got that y is equals to that. And then you plug in 9 over 16, and then 2 root 2, and then square. So that means you plug in the y into here. We use the orange too much, right? So let's try the highlighter. Okay, so that is a plug-in. And then 9 over 16, so that will be 8. That will be 8. And then you simplify that. That will be 9 over 2, right? 9 over 2. So x is square is equals to 9 over 2. X squared is equals to 9 over 2. So since x must be greater than 0, then the square root of then x is equals to square root of 9 over 2, which is equals to root 3 over 2. So therefore, we are going to recall. Let's draw a conclusion. Let's use blue. So we are going to recall that y must be greater than 0 and x must be greater than 0. That is given in the problem. So we have x equals to, you know what? That is supposed to be, this is not right. This is not right. So this is supposed to be 3 over root 2. X is equals to 3 over root 2. And then y is equals to 2 root 2. Y is equals to 2 root 2, and then the maximum value, so the maximum value of the function is, so f, when x is equals to 3 over root 2, and then y is equals to 2 root 2, so all you have to do is you do a 4 times x times y, so x is 3 over root 2, and then y is equals to 2 root 2, and then I can see that the root 2 is cancelled, right? And then 4 times 3 is 12. 12 times 2 is 24. So the maximum value is equals to 24. Hey, what is that mean? So this is what that means. So I already prepared a pictures. Yep, that is like right here. You know what? I already copy and paste. I already copied that. So this, the green is the objective function. So this is what the green ellipse represents. So the green ellipse represents x squared divided by, I believe it's a 3 square, right? Let me look it up. Yep. 3 square and then plus y square over 4 square equals to 1. So this is the ellipse. And this is also my constraint. Okay, and then how do I get the objective function? The objective function is 4xy. So the objective function is basically 4xy. So I have a ellipse that is my constraint. The ellipse has a size, right? So I'm trying to maximize the rectangle inside the ellipse. And that is my rectangle. So what we are going to do is, that is my rectangle. We have f of xy equals to 4 times xy, right? So the way we do this is, we call this a x, we call this a x, we call this a y, we call this a y. So the area of the rectangle is 2x times 2y. So that is how I got the 4xy. So since they restrict that x and y must be greater than 0, and then that stands for the area. So that means if you highlight this piece, so if you highlight the first quadrant where x and y are greater than 0, the area is 24. So that means in order to achieve this area, x must be equals to, so the x coordinate from 0, and then x must be, what did I get for x? So that will be a 3 over root 2. 3 over root 2. And then how about the y value? The y value is, let me look it up. The y value is 2 root 2. So 2 root 2. That is where you cut the x. So in order to achieve the largest area, so this must be 3 root 2. And then this must be 2 root 2. And then that is where you cut the x, where you cut the y, and then you get your rectangle in the first quadrant, and then the area is equals to 24. All right, so that is the end of this problem. If you like the way I explain math, give this video a thumbs up and subscribe to my channel for more contents like that. As always, I will meet you all in the next video. Signing out.